Hey everybody, Darren here, and today I'm going to be sharing my top 10 programming tips that will help you get a job working in Unity3D. I myself have worked in the industry and even advised employers on Unity3D programmer applicants, and these are some of the things that I'd wish I had seen when looking through the applicant's past work and projects. Just know that you don't need to be super smart or clever to get a job in programming. In fact, many of the items on this top 10 list are purely related to how well you organize and future-proof your code, and not how clever your algorithms are. Number 10, null reference exceptions. Null reference exceptions are easily the most common programming error to plague developers, at least in Unity, and they're really easy to prevent. Can you look at this code and see the problem? Null reference occurs when your code attempts to use a variable that does not yet exist in memory. It usually occurs when you expect a variable to be initialized by the time you begin using it, but another rendering cycle is required before that happens. Simply check whether the objects are null or not before using them. Number 9, the inspector. Sometimes complex classes get out of hand when they require user manipulation on nearly every variable. Don't let your inspector view get messy. You can use serialized classes to force Unity to categorize groups of public variables into dropdowns. Furthermore, you can use attributes to pretty things up if you don't know editor scripting. The header attribute will give you a nice bold label in the inspector, and the tooltip attribute will give the user of your script more information about each variable. Number 8, naming conventions. This varies between companies, but you should get into the habit of using naming techniques that help you and your teammates break down and understand complicated code more easily. For instance, you can use m underscore on all private variables. What I've been doing lately is m underscore on private variables and just underscore on local function scope variables. When I glance at the code, I know exactly what belongs to the class and what is only modified by individual functions. Number 7, modular code. Each class should be responsible for only one thing. When I say that, I don't mean they can only have one method definition. I mean you should have a clear definition for each class that you write. For example, your game manager can use the audio manager's functions, but it shouldn't contain the logic for those functions. Sometimes I see new developers writing classes that contain methods for moving the player, playing sound, and doing file I/O operations, and each one of those jobs needs to be abstracted by its own class: a player controller, an audio manager, and a file manager. Number 6, namespaces. Namespaces may seem useless on the surface, but they're a great way to organize your code. They are useful for organizing your classes into systems and providing you with an easily digestible way of connecting systems. As an example, by looking at my namespaces and using statements, I understand immediately how my software systems are interacting. In this case, I know my button system interacts with my audio system. You should extend this idea in your actual folder structure. Inside your scripts folder, you can name your subfolders according to your namespaces. Number 5, debug.log. Have you ever had a project with hundreds of debug lines scattered throughout your code? What if you only wanted to show a certain type of debug statement? You can create a class that wraps the debug functionality in a Boolean switch variable, and then anytime you modify the switch, it affects all of the log statements throughout your code. You can extend this idea to categorize your logs in whatever way that you like. For instance, if you only want your button event logs to appear, you would simply create a flag for that category. These are the types of wrapper classes that hiring managers love to see. You're not required to write them, but they definitely help you out in the long run. Number 4, third-party tools. Knowing how to work with third-party SDKs like Oculus, Firebase, and AWS, or any other tools and libraries is essential to your success as a developer. When you download an SDK for use in Unity3D, there are 3 main things that you need to do. First, you need to learn the API. Second, you need to find the functions that you need to apply to your own project. And third, you need to write a class that encapsulates the functionality from the SDK so you can use it reliably throughout the rest of your project. This wrapper class is really important. This is what acts as an intermediary API, and it's the only class in your project that directly communicates with the third-party SDK. This is useful because when the SDK changes or a version updates, you only have to update the code from one place, your encapsulating class. Number 3, design patterns. Learn as many design patterns as you can and determine which ones you want to apply to your projects. Design patterns help you construct your code in specific ways that make it easier to collaborate with others, prevent bugs, and improve readability. An example of a design pattern you should definitely be using in Unity is the singleton pattern. This pattern provides a way for maintaining a single instance of an object of a particular class. If another instance shows up, it's going to be deleted. This is useful for management classes that must maintain consistent data from scene to scene for the entire user session. Number 2, copying and pasting code. Never copy and paste code from online. The code may work, but if you don't understand why or how it works, you're leaving your software open to vulnerabilities and errors. That's all I have to say about this one. Number 1. Source control. Source control, or version control, in software is absolutely essential to the success of a project, especially when working collaboratively. There's a couple benefits you should be aware of. First, your projects can be accessed from multiple computers if you work on a desktop and laptop interchangeably. Next, if your hard drive fails, you can rest assured knowing that you haven't lost everything because it's actually stored on the cloud. You can set up multiple development tracks or branches for the same project, which is useful if you have a development track and a publish track. And lastly, if you accidentally corrupt your project, you can revert to an older, more stable version of your project and start over without losing everything. I highly recommend spending some time learning a few commands. The most basic understanding of source control would require you to know about clone, add, commit, push, and pull. We actually have a playlist to help you get a grasp of this topic, which I'll leave a link to in the description if you want to learn more. That's going to wrap up our top 10 list. Drop a like if you enjoyed it, and leave a comment on which tip was most useful for you. Thanks for watching, and I'll see you guys next week.